This is video 2 of your 1.2.1 notes, same learning targets. We're going to do another proof. This one, we're going to be given angle 1 and angle 2 form a linear pair. We have a diagram as well. And angle 2 and angle 3 form a linear pair. What we want to prove is that angle 1 is congruent to angle 3. So what this proof is actually the proof of the vertical angle theorem. Again, theorems become theorems after they have been proven true by mathematicians. So we're going to do the actual proof for it. So we start off with our first statement. What should it be? Again, you can pause the video and think. What's our first statement and reason? That's right. First statement is what's given. And we want to say that angle 1 and angle 2 form linear pair. I'm just going to go LP for right now. Linear pair. Okay, I can do another statement. I guess I will. I'm going to say angle 2 and angle 3 form linear pair. My class, I wouldn't lose sleep if you put both those statements on the first statement. You said both things, but our reason is going to be given and given. All right. So we want to work towards proving that these angles are congruent here. So we got to start with what's given. What can we do with that information? Angle 1 and angle 2 form a linear pair. What do you know about a linear pair? Oh, aren't they supplementary? Right? We know that this angle plus this angle equals 180. They're supplementary. We also know that this angle here plus this angle here are supplementary. They add up to 180. Okay? So let's write that down. We know that angle 1 and angle 2 are supplementary. Oops. What's our justification for that? That's the postulate. Linear pair postulate. All right. So our fourth statement, we're going to say the same thing here. We're going to say angle 2 and angle 3 are supplementary. All right, and the same justification. It's the linear pair postulate. All right. Well, how can we use supplementary now? We know supplementary angles are two angles that add up to 180 degrees. So can we talk about the measures of these angles now? So let's do that. Statement 5, we're going to say the measure of angle 1 plus the measure of angle 2 equals 180 degrees. Why? That's just a definition. Definition of supplementary. All right. We're going to say the same thing here for 2 and 3. So for 6, we're going to say the measure of angle 2 plus the measure of angle 3 equals 180. And definition of supplementary angles. Look at statement 5 and 6 now. This should start to ring a bell. What can we do if I have these two angles equal to 180 degrees, and I have these two angles equal to 180 degrees? What did we do in IM1 when we had that situation? That's right. We're going to do substitution property, right? We can take the measure angle 2 plus measure angle 3, and we go, boop, replace 180 with that because these both equal 180. So we're going to substitute that for 180 and rewrite the equation. So we're going to say the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. Substitution property. Say substitution. All right. Do you see something that's the same on both sides of the equation? You see we have the measure angle 2 on the left and we have the measure angle 2 on the right now. What can we do with that measure? That's right. We can subtract it from both sides using our algebra. So we're going to say the next step, if I subtract the measure angle 2 from both sides, I'm going to be left with the measure of angle 1 equals the measure of angle 3. Aha! The vertical angles are equal. Their measures are the same. Okay? And why was I able to say that? Why can we go from here to here? Justification for that? Subtraction, property of equality. So I'm going to say subtraction, POE, property of equality. Not just subtraction. Property of equality means I subtracted the same thing from both sides of the equation. Okay? And then, are we done? What do we need to prove? Angle 1 is congruent to angle 3. We're so close, but we're not quite there. So our last statement, if the measures are the same for those angles, can I now say angle 1 is congruent to angle 3, right? And we know that the measure, any angles of the same measure are congruent. That's just a definition of congruence, or definition of congruent angles. Definition of congruent angles. That's it. So we've done the proof. And so from now on in our class, we can use this. This is going to be called the vertical angles theorem. So the vertical angles theorem says that all vertical angles are congruent. That is the vertical angles theorem. So anytime we see vertical angles, we know they're congruent, which then means we know that their measures are the same. Thank you.